You know that feeling when you buy a new piece of electronics, unbox it, and, well, you realize it uses a completely proprietary charging cable?
Oh, I hate that.
Right. You've got a drawer full of perfectly good standardized USB-C cables, but this one specific gadget demands its own weird, unique connector.
Yeah, and if you lose that one specific cable, the device is basically a brick.
Exactly. It's completely useless. Welcome to today's deep dive, by the way. If you've ever felt that exact frustration, you are going to relate heavily to today's topic.
We've all been there.
We really have. Whether you're a seasoned developer or just someone learning the ropes, or even just someone interested in how complex systems are put together, today is all about the universal struggle of making things adaptable.
And readable, which is just as important.
Absolutely. So our mission today is to explore a really fascinating case study in software simplification. We are looking at a set of notes published on May 25, 2026 by a developer named Ang.
Specifically, we're diving into a post titled Notes on Haskell Programming, Part 144.
Yeah, part 144. And we're going to explore Ang's journey of refactoring a Haskell command line interface pipeline, or a CLI pipeline.
Moving it from this highly specific, tangled internal state to a much cleaner, generic representation.
And I'm so excited about Ang's ultimate takeaway here, because it proves that complex programming languages don't have to be unreadable. They really don't.
No, they don't. That is a crucial distinction. I mean, the language gives you the tools, but how you arrange them determines whether you're building a standard plug or, a proprietary nightmare.
A proprietary nightmare is the perfect way to put it.
Right.
So before we can appreciate Ang's solution, we really need to understand the structural problem in the original code base, the before state, basically.
Right. The mess they started with.
Exactly. Let's start by examining the original validation function. Ang was working on this function called validate args, and it was meant to take the arguments a user types in and figure out if they're actually valid.
Seems simple enough.
You would think so. In the original code, the function took in those raw arguments, but what it spit out was this heavily wrapped object called a ParserResult.
Ah, yes. The parser result.
Yeah, and this wasn't just a generic container. It was tied directly to the internal state of a specific parsing library called opt-parse-applicative.
Which, to be fair, is a very popular Haskell parsing library.
Sure it is.
It does the heavy lifting of interpreting the command line inputs, and it's a powerful tool for that specific job. But the architectural flaw happens when that library's highly specific data type, like the parser result, leaks out of the parsing stage.
And it starts infecting the validation logic.
Exactly. It couples the two together.
So this is the proprietary charging cable from my analogy earlier. It's like wiring your entire house so that every single electrical outlet only accepts one very specific proprietary brand of toaster.
That is exactly what it's like.
And if you want to plug in a lamp, well, you're out of luck. The validation function isn't just handing you back your validated data, it's handing it back wrapped in the custom packaging of that one particular parsing library.
And it creates a severe coupling issue.
Yeah.
Because suddenly, the validation logic needs to know about, parser preferences and parser metadata.
Things it has no business knowing about.
None at all. Conceptually, validation shouldn't care about the parser.
You can really see the weight of that when you look at the original error handling Ang shared. To just spit out a message saying, hey, there's an error with this file path, the code had to do so much extra work.
Bro, it was a mess.
It had to call a custom failure function, drag along an object for parser preferences, drag along another object for parser info, wrap the text in a custom error message type, and then pass along an empty list.
Just for a basic file error.
Just for a basic file error, all that baggage. So I have to push back a little bit here. Why would a developer end up with this tangled parser result state in the first place? I mean, did Ang just make a rookie mistake?
Well, no, not really.
Is it just the default way this opt-parse-applicative library forces you to work?
It's kind of a trap, but it's an incredibly common one. And it usually stems from just taking the path of least resistance.
Okay, what do you mean by that?
When you first integrate a library like opt-parse-applicative, you're just following its documentation.
Right.
And the library is designed to handle errors robustly for power users, so it provides these really rich, complex failure states. When you're in the flow of writing the initial feature, you just use the tools the library hands you.
You just stay in their ecosystem.
Precisely.
Yeah.
It feels natural. You don't realize the long-term cost until later.
You just keep threading the cable they gave you.
Yeah. And by leaking that specific parser state into the validation logic, You've glued the two together.
Mm.
So if you ever want to use that same validation logic somewhere else, say in a graphical interface or a web backend, you can't.
Because it demands the specific context of a command line parser.
Exactly. It makes the code incredibly rigid.
Wow. So it's harder to test, harder to modify, and as Ang found out, much harder to read.
Much harder.
But standardizing the data type is where Ang makes the pivotal shift. This is the after state. Instead of returning that messy proprietary parser object, Ang changes the function to return something called an either type.
The either representation.
Yes. Specifically, returning either a simple string or the successful validated data.
Which decouples it entirely from parse applicative.
Okay, let's unpack this because this is huge. If the old way was the proprietary coaster outlet, moving to the fighting, either type is like finally installing standard universal electrical outlets.
That's a great way to look at it.
But for the listener, what is the practical benefit of standardizing return types across a main CLI pipeline using something like either string? Why is this the ideal universal adapter?
Well, the either type in functional programming is just really elegant because it represents a clean binary split. It literally means the data is either one thing or another. Conventionally, the left side of the either is used for errors, and the right side is used for success.
So in Ang's new setup, the error side is literally just a plain text string.
Yes, just a simple standard string describing the problem, like file not found. And the success side is the actual data you wanted.
Notice what has been completely removed from this equation.
Everything. There are no parser preferences,
No parser info.
no custom wrappers. It's purely domain data now.
Wow.
By shifting to either, Ang established a clear boundary. The validation function now essentially says, I don't care how you display this error to the user. I don't care if it goes to a terminal, a log file, or a pop-up window.
Here is a standard text string. You deal with it.
Exactly. You handle the presentation.
That decoupling drastically simplifies the overall code base. It allows different actions in the pipeline to communicate using a common language rather than, library-specific jargon.
Which is how a pipeline should work.
So having established the structural shift to tether, we now need to look under the hood. Let's look closely at the actual validation checks Ang was performing inside this function.
Because the checks themselves are pretty interesting.
They really are. First, the code extracts the file path. It uses args at args input path equals path. And then it simply uses does file exist path to see if it's there.
Which is very standard.
Right. But then Ang has to check if the file is actually text, the isText check, and specifically if it's UTF-8 encoded text.
And this is where theory meets reality in system architecture.
Yeah, how do you definitively prove a file is text without slowing down the entire pipeline?
It's a tough problem.
Here's where it gets really interesting. Instead of some abstract philosophical check or parsing the whole file, Ang's code grabs just the first 1,024 bytes.
The first kilobyte of data.
Yeah, just a small chunk. And then it simply scans that chunk to see if there are any null bytes present, zeros.
Not any equals zero chunk.
Right. If it doesn't find any zeros, Ang just says, if there are no zeros here, it's text.
It's a fantastic, highly effective heuristic.
But why does that work?
Well, to understand why it works, you have to look at how data is encoded. Standard text files, especially those using ASCII or UTF-8 encoding, use specific numeric values to represent characters.
Right.
And in those standard mathematical sets, the null byte, the absolute zero, is almost never used in standard readable text.
But binary files use them all the time?
Constantly. Compiled programs, images, compressed archives, they're fundamentally structured with null bytes acting as padding or structural markers.
Oh, wow.
So if you scan a random kilobyte of a file and hit a zero, the statistical probability that it's a readable text file drops to almost nothing.
That is so pragmatic. It isn't some complex algorithmic validation. It's just a quick sanity check. Look at the first 1,000 characters. Any zeros? No. Good enough.
It really is good enough for most CLI tools.
And restricting it to just 124 bytes is a deliberate memory management choice, right?
Oh, absolutely. I mean, imagine if the user inputs a 50 gigabyte log file.
Oh my gosh, yeah.
If your validation logic tries to read the entire file into memory just to confirm it's text, you'll crash the program before it even starts doing its actual job.
Just evaluating it would break it.
Right. By isolating a small chunk, the evaluation is practically instantaneous, regardless of the overall file size.
And after that, Ang runs a similar isolated check to ensure that text is specifically valid UTF-8. Using isWrite, decode UTF-8 on that same chunk.
And then passes all of that into the final validate function.
Right. But I want to connect these low-level byte checks back to our earlier discussion about the parser.
Okay.
If you have these highly specific byte-level checks tangled up with the parser's internal error messaging from segment 1, debugging would be a complete nightmare, wouldn't it?
The mental load on the developer is massive.
Can you elaborate on that? Because it seems like it would just be so confusing to track.
It is, because when you mix low-level byte logic, like checking for UTF-8, with high-level parser failure states, your working memory is overloaded.
You're trying to hold two completely different domains in your head at once.
Exactly. You're asking yourself, did my null byte scanning logic fail? Did I grab the wrong chunk size? While simultaneously wondering, did the parser fail to construct its internal preference object correctly?
You are debugging the file system and the user interface at the exact same time.
And that is a recipe for burnout. Decoupling allows these neat, specific checks to exist independently of how the errors are eventually reported.
You can write a test that just passes a kilobyte of data to the isText function, and it returns true or false.
Doesn't need to know anything about the terminal. It's clean, and it preserves the developer's sanity.
But the simplification wasn't just about changing data types. It was also about changing the visual layout and flow of the logic itself.
The readability revolution.
Yes, because even if the data is clean, if the human eye can't track how that data is being routed on the screen, you still have a readability problem.
We spend far more time reading code than writing it.
So true. And Eng's notes detail a transition away from using guard clauses for the final validation logic, moving instead to a case statement.
Which is a very deliberate structural shift.
Right. Eng specifically notes that the previous guard clauses were harder to follow and cumbersome to trace, and that the new code is much easier to read.
It really is.
So what does this all mean for the person actually reading the screen? For someone who might not know the conceptual difference between a guard clause and a case statement, why is a case statement vastly superior for tracing this kind of logic?
Well, let's think about how we process lists of rules. Imagine a guard clause as a bouncer at a club with a long sequential checklist.
Okay, I like this.
The bouncer looks at you and checks condition 1. Are you over 21? If yes, move to condition 2. Are you wearing the right shoes? If yes, move to condition 3.
It's a linear top-to-bottom cascade.
Exactly. It's a cascade of true-false Boolean checks.
That seems logical enough. Why is that bad? Why did Eng find that cumbersome to trace?
It works beautifully for simple, linear rules. But when dealing with multiple validation states, like we are here, it breaks down.
Because we are checking if the file exists, if it's text, and if it's UTF-8.
Right. When you try to represent all the possible combinations of those three states with a linear cascade of guards, the logic gets incredibly murky.
You end up doing mental gymnastics. Okay, if the file exists but it's not text... Wait, did I already check the UTF-8 part?
Your brain has to keep a running tally of which conditions evaluated to true or false on the previous lines just to understand the current line you're reading.
That sounds exhausting.
It is. A case statement, on the other hand, provides a clearer, more structured path of execution. It operates more like a routing desk.
How so?
It looks at the shape of the data as a whole, all at once. You pass it the results of all three checks simultaneously.
So you bundle the results together, exists, valid text, valid UTF-8.
Exactly. And the case statement acts as a map. It says, in the specific case where these three are true, 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 execute this path. In the case where they are true, false, false, execute that path.
Oh, I see. It maps the exact combined state directly to the exact outcome. You don't have to trace a cascade. You just find the pattern that matches.
It avoids a tangled mess of conditions. It leverages human visual pattern matching. We are very good at looking at a block of organized cases and finding the one that applies.
But we are terrible at holding a cascading series of true-false evaluations in our working memory.
Exactly. By switching to a case statement, the human eye can easily track the flow.
It's so elegant. So we zoom out from the specific refactoring of guards, case statements, and byte strings. Because there is an ultimate lesson Eng leaves us with regarding the Haskell programming language itself.
And it challenges a very pervasive narrative in the software world.
It really does. Haskell often has a reputation for being dense or overly academic or just inherently complicated.
People assume the language itself forces you to write confusing code.
Right. But Eng concludes the notes with this reminder. It's entirely possible to write simple, readable Haskell code, provided you use the right language constructs.
Which is the thesis of the whole post, really.
Does Eng's rewrite prove that when code is hard to read, it's usually a choice of constructs rather than a limitation of the language?
I think it absolutely validates Eng's core belief. Knowledge and complex tools like Haskell are most valuable when understood and applied clearly.
Yeah.
There's a tendency to blame the tool when things get complicated. But the refactoring from ParserResult to either wasn't just a technical necessity.
It was an active choice.
It was an active choice to prioritize human readability and simplicity. Ang chose not to lean on a library's default complex constructs.
Because you have agency as a developer. The language provides the vocabulary, but you still have to write the sentence.
That's beautifully put. You don't have to let the library's internal complexity become your application's complexity.
So, to sum up this deep dive, by standardizing return types to a universal adapter like either actively decoupling from op-parse applicative and switching from cumbersome guards to clear case statements, Ang turned a complex CLI pipeline into simple, readable code.
It's a masterclass in defending the core of your logic.
It really is, and it reminds us that whether you are writing code, organizing a project, or even just setting up a filing system, choosing the right simple construct makes all the difference.
It does, and it leaves us with a really vital thought to mull over, building directly on what we saw today.
What's that?
Well, Ang showed us the danger of letting a specific parser dictate the flow of our validation logic. It makes you wonder, in your own work, whatever field you happen to be in, what other domain-specific tools or wrappers are secretly bleeding into your core logic right now?
Making things infinitely more complicated than they need to be.
Exactly. Where have you adopted a proprietary cable when a universal standard would have been so much better?
That is a fantastic question to end on. Thank you for joining us on this deep dive. Keep questioning those assumptions, keep seeking simplicity in the complex, and we will catch you next time.